Hey everyone, welcome. Today we are jumping into the fun mechanics behind Java generics and great object-oriented design. Before we start coding big data structures like search trees or priority queues, we really need our core developer toolkit ready. Think of this lesson as grabbing your favorite set of tools, because a great data structure is not just a bunch of variables tossed into memory. It is a clean, reliable piece of code that you can reuse anywhere without headaches. Here is what we are packing into our toolkit today. First, we will brush up on object-oriented design so our classes stay neat and modular. Second, we will master Java generics so our collections can safely hold whatever data type you want without crashing. Third, we will build a simple container called boxadt to watch an abstract data type in action, while also checking out how to sort custom objects and seeing how iterators make Javas for each loop work under the hood. Now, let us talk about object-oriented programming. Instead of writing messy scripts with loose variables all over the place, object-oriented programming organizes everything around smart, self-contained units called objects. An object simply bundles private data with the exact actions that work on that data, giving us a solid way to build data structures that never break. Our first pillar is encapsulation, which basically means keeping your data safe inside a vault. Think about your favorite banking app on your phone. You definitely do not want some random outside code reaching in and changing your balance to zero. Instead, that balance variable is kept strictly private, and people have to go through secure deposit and withdrawal methods that check every detail, keeping your internal storage arrays completely safe from bugs. Our second pillar is inheritance, which lets a brand new class borrow all the cool features of an existing parent class. Picture cars on the street. A standard car class already knows its speed and how to accelerate. A new electric car class can easily grab all of those standard features while simply adding its own battery charging tricks, saving you from ever having to write the exact same code twice. Our third pillar is polymorphism, which lets different objects respond to the very same command in their own unique style. Imagine a universal game controller with a single action button. If your character is holding a flashlight, pressing that button turns on a beam of light. But if your character is holding a sword, pressing that same button swings the blade. In Java, polymorphism lets a single list hold multiple shapes, calling an area method on each one and letting the right math happen automatically. Our fourth pillar is abstraction, which means hiding all the messy machinery so users can focus on what actually matters. Think about driving a car down the street. You tap the gas pedal to speed up, and you turn the steering wheel to make a turn. You do not need to understand engine combustion or fuel injectors just to enjoy the ride. In the exact same way, when someone uses our queue, they only care about calling enqueue and dequeue without worrying about how array resizing works behind the scenes. Mastering these four pillars turns ordinary coding into great software engineering. Encapsulation protects our data. Inheritance cuts out boring repetition. Polymorphism brings awesome runtime flexibility, and abstraction keeps our interfaces clean and simple.